Welcome everyone to this week's OMR Architecture Meeting. Today we have two topics. They're actually both compiler topics. The first one is a bit of an architectural discussion around power instruction fusion support that Abdul Rahman will take us through. So why don't we start with that one? And Abdul Rahman,
yeah,
take it away.
Okay. Can everyone hear me?
Yep.
Yeah. Okay. Okay. So for power, so we have with B10 starting, we have this new instruction fusion feature, and like this support structure hopefully allows OMR to take advantage of it by knowing which structures can fuse and which not. If you or I can show the PR, maybe just to go over.
If you could share, that might be better, just so you are in control and you can drive.
Yeah, I'll share that. Okay. So maybe I'll start with the example just to show the fusion because it has like two levels kind of thing. So we have the normal, if we have two adds, for example, the adds fuse, if the target of the first instruction is one of the sources of the second instruction. But that fusion does have to be issued twice because there are two target registers that needs to be set. But if it's used same target register, it's only issued once. So that's the perfect kind of goal, is having it like to the same, reuse the same register in the target and having follow the conditions to fuse. So that's kind of the perfect, or this fusion also kind fuses, but has still to it be issued twice. So I started with a simple design. Before the design, maybe we can go over the things that the design should have. It has to support multiple instruction formats. For registers, there's no condition, or there's a condition on a register. There's cases where the general register 0 is a specific condition. For example, in ADI and II is shifted. As been mentioned, like OMR doesn't support 0 in RA on these. It uses LI. But that's something to consider maybe in the future. Do we want to have it like having specific registers be a condition? Maybe it should be in the design. Immediates, either there's no condition in immediates, or there is a condition, because some have a condition being like 0, 1, -1, I think even 63 in one of the shift fusion conditions. Also for formats, there's some conditions where like there's an add, the instruction 1 can be add, subtract, or like multiple formats to many instruction 2. So you have like 2 instruction 1 formats specified, can fuse with any of the 4 instruction 2 formats. So that gives like 8 possibilities. This is maybe an issue between memory usage of this structure and maintainability, because if we split the formats in a different list and have the structure like points to these formats, maybe it's going to be harder to maintain and like an extra pointer to follow. So maybe the memory usage is kind of still worth it. Source register interchangeable. So for target 1, source 2 instructions with 1 target, 2 source registers, most, if not all, like all I have seen is they allow fusion if the source register, if the register, like in the example, if Rx here was in the A or in the B. So it allows both in almost all cases. So that's something that we don't want to double register every fusion pair twice, because like that would be allows memory, useless memory. We can have like maybe a Boolean that tell it that, oh, it can be here or here, and that all works for the fusion. Yeah, and then like we're assuming two instructions and access to the structure. Given like Julia mentioned that the gain from instruction fusion is not big, so access to the structure should be quick to not cross the break-even point of being slower after using the structure, and that's kind of break the performance. Like we want better performance, not slower. And that's the kind of the main points of what we want from the design. I have like a very simple design, like kind of just to see what issues goes with it. But maybe before that, I don't know if there's any questions or ideas about like what to look for.
Well, I'm just trying to get my head around like what it is that you're wanting to try and do. Are you proposing some kind of instruction scheduling and like some constraints on the register assigner, or are you trying to like change how you generate the instructions or have multiple I'm just trying to get my head around exactly what it is that this is proposing.
Yeah, so these ideas are like, I started with a beephole idea, but before going into that, like that beephole needs a structure that tells it which instructions can fuse together. And this is kind of just the structure that stores, oh, this can fuse with that or doesn't. So, and like if I go to the code, for example, I have instruction, which is like a fusion bear that holds instruction 1, instruction 2, and like instruction 1, instruction 2 are like format. And if I go to an example, maybe I'm going to pay. So it's just holding, oh, for this instruction, these fuse. So it's just a structure to hold what instructions can fuse. Then whatever else in OMR can use this structure to know, oh, these fuse, so we can do something with it. So it's not optimizing anything yet. This is the structure that whatever feature will use to know what thing's gonna use.
You mentioned this is you expect this to be a peephole pass. When do you want to do that peephole pass? Is this after register assignment or before?
So it could be also like this structure could be used also in register assignment to assign the best register for fusion. And then for peephole, the idea I have is like a reorder, because the fusion window is just like consecutive instructions. So the basic peephole idea was to reorder the instructions that can fuse to fuse. But it can be also used in register assignment to assign the best register for fusion.
Okay.
But don't you need something bigger than a peephole in that case? Because if the register assignment is going to be impacted, then if you want to get maximum fusion, you not only need you need to schedule the instructions as well as the registers, right? Like it becomes a larger optimization problem because you have two variables, right? And if you just generate whatever sequence you would generate and then try and do these tweaks, you're not going to really, like, you'll get some fusion, but there'd be a lot of fusion you'd miss out on because it wasn't considered as part of the overall sequence.
So it should, like, mainly it should be an instruction schedule, but as far as I know, there's no instruction schedule. The next in mind was a peephole and a register assignment. I'm not sure if there's like something else that can have like a whole holistic kind of look over it before, because when a node convert to instruction, there's like set nodes to set instructions. Is there something else that can be done here? My idea just yeah.
I mean, I mean, many years ago, we used to have an instruction scheduler that ran on Power, but that didn't survive open sourcing, so it's not there. So we haven't had this kind of capability or needed to do this kind of capability in some time. So this is the only fusion that do you know if this is the only fusion that we do right now in the backends? Like, for example, does Z do anything, or Anywhere else in Power that has Fusion?
Yeah, we do it on Z. It's just literally the simplest possible peephole pass. This seems a bit overkill for Fusion.
Yep. Because for Power, at least like in P10, there's maybe 600 or 3. If we count the interchangeability as like a separate one, there's like 600 pairs. So it's kind of more larger pairs that can fuse. So it's just like having a structure that holds all these, and then like whatever people, whatever else can use the structure to kind of optimize the code.
Okay. Why don't you get into what your proposed design is?
My proposed design is similar to instruction properties. And then what it starts with, so I have like a Fusion format, an instruction format that holds this target, source one, source two. That's for one format. I'm just like working on one format right now. And then like I get 2 of these formats in one pair, and that's like, and I have then a list of pairs. This has many issues. This is like the simplest idea, because this first, if we want to access a Fusion pair, we have to iterate over everything, and it takes a lot of memory, and not maintainability could be a good for it, but it's not even great.
But you have the registers stored as int8s. Is that because you're using the enum value of the real register? Is that what's being stored there?
So it's int8 because for register here, I'm having, if it's -1, it's like, it's not a Fusion condition.
Oh, I see. Okay.
Yeah.
Oh, I see. Okay.
So that's kind of the, and then hoping like to increase formats, add whatever else needed. Like a better idea that got in my head is like having a hash table, because that's much quicker. So having a hash table, the hash key would be like the opcode of instruction 1 and instruction 2. Because like if we want this structure to be quick, because the gain from Fusion itself is not big, it's not that big. We need the structure to be big, to be fast. So having a hash table to access, I'm trying to limit the search space for pairs, and then like comparing until finding a pair that match or not match. Okay, if a peephole goes through instructions, takes an instruction, it looks in the hash table, is there a pair that matches with the one after it, for example? Or like it goes after like a window, for example, 20 instruction, it goes until if it finds one that matches in a pair, it reorders it if possible to be consecutive. So the hardware kind of fuse it.
Is there any possibility of extending the instruction metadata service, like the instruction properties?
That's one idea that I saw. We can add like an extra property, but then then we would have like different lists. That's I haven't thought a lot of it, but it's possible to add an extra property. But how do we like, because we can point from instruction 1 to many instruction 2s, but then if we want to go the reverse way, that could be an issue. Like if we can have a structure that finds all instruction 2 possible for this instruction 1 that can fuse, but if we want the other way, I'm not sure if it's something that we want that's going from instruction 2 to instruction 1, but if having it general enough that it does, it would be better, but maybe we
wouldn't list them in your current design anyways?
Sorry, say it again, pardon?
Like in your current design, you need to list the pairs regardless.
Yeah, so the current design is, it has a lot of issues, just like I wanted from it, it's kind of raised issues to tackle from this design. So a hash table was a good idea, I think. Instruction properties, we could do something with that. I have to look over it. How exactly do we find, because we can add a property for instruction for like the Fusion group, for example. But then even that, like we'd have a huge Fusion group because, like, for example, an add fused with a lot of things. In a hash table, I think with an opcode of instruction 1 and opcode of instruction 2, that would like really reduce the search space.
I mean, if you're using something like a hash table, you might run into problems with trying to fit that whole thing in the CPU cache. So I don't know that using both opcodes and doing lots of lookups into that thing would really help performance.
Why is, like, I feel like when we have both opcodes would be fewer lookups, because it like how many Fusion
So
variables
if your key is both opcodes, then every time you want to check if a pair of instructions can be fused, you'd need to do a full lookup on the table. So you'd need to do a completely separate lookup on the whole table every time, and that would tend to just fluctuate randomly around the table. It wouldn't have any nice caching properties.
Okay, I see. Yeah, that could be a hash table. I'm trying to find the best like structure, because obviously a normal array is not the best. Hash table has its issues. Yeah.
Honestly, I think we might need to know more about what exactly it is you're proposing and how you're going to use this before we can decide on a design for the structure.
Yeah, I don't get a lot on how I'm gonna use it, because I'm thinking of having it generally, like as a general structure for beep holes or others to use it. But if we talk about the beep hole, maybe a beep hole that goes over the instruction. For each instruction, it goes like for a window, let's say 20 down. It goes to the next 20 instruction. It says if there's an instruction that could fuse with the first instruction, and if possible, reorders them so they fuse. So that's kind of the basic idea of the first.
I would say implement that, and by you'll discover a lot of implementation details that you might not have thought of. And it'll help the committers review the code better than just an arbitrary design that may get used in a bunch of places, but may only get used in just a beep call.
Okay. So, and have like a symbol structure for, because the beep hole would need the structure. So have a symbol structure, work on the beep hole, and then come back to the structure and modify it. That would work. Yeah.
Yeah, the comment I would make is that it would also be good to understand the benefit that it provides for the complexity and compile time and memory increases that it causes in the compiler, right? If the benefit is very marginal and the code is going to be extremely complex or make debugging the compiler a lot harder, I think that would be a concern, right? If the benefit is marginal. I mean, if you can show that there's a good benefit, then complexity is warranted, but I think we just need to be a little careful on the trade-off there, right? Because if we design something really complicated and the instructions get reordered and changed after they've been selected, and that makes debugging harder, and yet it may not give us anything, is one concern that comes to my mind.
I was going to say much the same thing, because earlier you mentioned that you didn't expect to see much performance from this. So the question that I had in my mind as you were going through this was, how many opportunities do we think we're actually going to find with this kind of analysis? Because if the opportunities are going to be fairly few, yet the analysis is somewhat expensive, then it probably isn't a great trade-off, and you may want to save this for only the most, the hottest pieces of code or scorching methods or something like that.
True. Yeah. I don't believe it's gonna give a huge gain, but I'm not sure if it's gonna be like would it be a less than a break even, or it's going to be just costing more than it uses? So that should be something that I'll look into more, and how much it's going to cost versus how much it's going to gain from it.
Yeah, I think that would help.
On top of the structure itself, we would have like other, like for example, the peephole. So the structure itself, there's no cost for it per se, but it's the cost of accessing the structure by whatever else is going to use it. Was it a peephole? Was it the register assignment?
Yeah, I mean, one of the reasons that, like I had mentioned, that we used to have an instruction scheduler on Power and on Z prior to open sourcing. I mean, one of the motivations behind not open sourcing it, and not consuming it in the open products, is that we didn't really measure a whole lot of benefit from it. It was doing a lot of analysis, but in the end, we could tolerate the very minimal amount of performance, losing the very minimal amount of performance that we were getting from it versus the complexity of doing all that analysis. So I'm hoping that this feature isn't going to fall into that category. I'm hoping we might see more from it, but it certainly is something to keep in mind as you proceed with the design.
Yeah, like the design, I tried as much as I can to have it like general and abstract, to like allow future fusion bears, allow future, maybe the window's going to expand, maybe, I don't know if it's going to like using more than 2 instructions. I don't know what the future is going to bring. So I'm trying as much to have it general enough, at the same time having it like work.
Yeah,
I'd
the
probably
danger with
avoid
going too
over-engineering.
general is, the danger with going too general is that it's going to be more complex than it needs to be and burn more time and space than it needs to do what it's going to do.
Okay. And for, I'm guessing maintainability is like trying to have maintainability is a good thing too. Memory usage, I think it's going to be like for this symbol structure, it's going to be around like the 5-6 kilobytes. I'm not sure. Like I know OMR is like wants as little memory usage, but how much? Like would that be a big effect?
I think most of these come to a cost-benefit trade-off, at least in my mind, but others may have other opinions, right? Like, if you want to burn 5K, but you give us 20% throughput, well, no duh, we'd do that, right? But like if it's 5K and 0.1% throughput that's hard to measure, maybe it's not a good trade.
Okay.
The other thing is that if there's certain kinds of code that would tend to produce more fusion opportunities, then perhaps limiting it to that kind of thing. So for example, if I don't know if this applies to floating point or not, or if it's only just GPRs, but if it did apply to floating point, perhaps restricting it to methods that had floating point or to blocks that had floating point would be the way to do it.
That's a good point. Yeah. Because even for people, like I was thinking like going over the whole code was not the best idea. And like probably specifying some code that would be better.
Yeah, that
Were
would
you
be
thinking of
next
this as a?
Sorry, go ahead, Daryl.
I was just going to follow this. Were you thinking of this as a global analysis, or were you thinking of doing this just on a basic block by basic block, like the local register assigner would do?
Haven't thought much of that between the two. I won't say that I have thought between the two.
Okay.
What I don't know. Maybe I'll ask. What do you think is better? I'm guessing the block by block.
The instruction scheduler will work for extended basic blocks.
Okay.
Yeah. It would come down to how many opportunities. Like you may find more opportunities by widening the field of search by considering, all blocks, but from a implementation point of view, it may be a lot easier just to focus on a block, extended basic block at a time. I don't know. It kind of comes down again to how many opportunities you expect to see and where they're coming from. know how to
yeah.
make that decision.
Okay.
Yeah, limiting it to hot blocks only or blocks with opportunities only helps with the compile time or resource usage question, but doesn't help with the implementation cost and maintenance cost aspects. Those are two different types of concerns.
Okay. Maybe I'll start like if it's easier to go general and like easy to modify it later to a basic block, or like go from one to the other, seeing what each kind of gives.
It's probably easier to start with block by block as opposed to starting general and then restricted to a block.
Yeah,
Okay.
those two things end up looking very different most of the time. And if you're going to go across blocks, then you have to worry about things like the global register assignment that might have happened and all kinds of other things and various control flow issues and things. So if you're trying to keep this simple, extended basic blocks would be where I would start.
All right. That's, yeah, I have very good points here. Anything has anything else? No?
Well, I mean, if you're considering designs, I mean, there are things other than peepholes that can achieve this kind of thing. I don't know if you've considered any of those or how well those would fit with what you're trying to do. But I mean, it's things like bottom-up tree rewriting and various other kinds of techniques that can be used to produce optimal instruction sequences if there's enough benefit to be had from the fusion, right? If getting it right is that important, there are other ways of doing it that are less fragile.
Yeah, and that's like one of the things I tried just writing a simple Java code and see how the compiler is going to do. And like already like reordering in the trees, like kind of moved things near each other in a good way. So yeah, maybe yeah, that's a good idea. So maybe I'll look into that too.
Yeah, I would say for concrete things, implement in a very naive way the peephole pass with as many fusions as you want, and then measure, see how much performance it provides and the compile time performance it consumes, and then do an analysis.
The problem is that, as I understand, we can't know how much we'll get right now because P10 is not generally available, and even internally, I'm not sure what the status of getting P10 machines to do performance testing on is. I think this might be a bit premature.
Maybe. So if it's issues, having the code maybe just running and then having it like having like even going and seeing oh, these would fuse or not, how much fusion, because maybe in the whole after the whole thing like we have only 1 or 2 fuse, then like you can already see even without P10 there won't be much. So yeah.
Right, but I mean, the raw number of fusions is not like, you could implement all this and simulate how many things might fuse, but the number of fusions does not determine the performance, right? Because the fusion may give a large performance benefit, or the fusion may provide only an incremental performance benefit. And if it's only incremental, even if you have millions of them, you may not even really be able to observe it. So unless you can measure it and justify the complexity, and we can understand the trade-off, that would seem to be the key point, right?
Yeah, I think it's more gonna show if we're not it's not kind of, the gain is small. If it's like only a couple, then we can see that the gain is small. If it's more, then we use the machine.
I guess that comes down to how much development effort are you wanting to invest in something that may or may not pay off. That's outside this discussion. It's just
true. Yeah.
A pointer that in making an argument for this kind of complexity and for this kind of thing, a raw number of fusions is probably not going to be sufficient for all of the different people who would be reviewing this and weighing up the pros and cons of the contribution. Right? The actual benefit of those fusions is also an important part of the equation. Ben or others, if you feel otherwise, please speak up, but I think that would probably be a fairly general assertion from most people.
Has this feature been implemented in any static compilers yet? So for example, does GCC have Power 10 instruction fusion support? And because presumably if you could get access to a Power 10 machine, they're probably fairly hard to find, but if you could, and you could possibly do some performance runs with and without that feature enabled, just to get an idea on C code, C++ code, just to get a general sense of what kind of performance you'd expect in kind of general purpose code. Not sure if that's possible or not.
Yeah, that's a good point. I'll see if we can do that. But yeah, maybe before going and implementing anything, that would be a good thing to test. If that's everyone's points, I think I'll head back. Thank you, everyone. Like, I got a very good amount of points here, and I'll look over them and see, hopefully get back to you with a good answer.
Okay, thanks, Abdul Rahman. Okay, so I think I'm up next. Let me share my... Can you see my my browser window?
We can.
Yeah, okay. So no formal presentation, unfortunately. Just sort of a quick introduction to something that I'd like to propose. I'd like to get some feedback on it, proposed design, perhaps alternatives, that kind of thing. So, so the motivation for what I want to talk about is really to think about how the code that we are currently generating in the back end can be used in different kinds of compilation scenarios. So those that are familiar with it will see that it's really, a lot of it has been really designed to work in a dynamic language concept. So the code that you ended up producing lives in a code cache, and it's expected to be executed dynamically. That works just fine for many dynamic languages. It works fine for Java. Other applications that we've moved this code into, it's been a good solution. But when we start to think about using this in other contexts like static compilation, where you want to be able to target use it in a static compiler to, let's say, generate an object file. So you want to produce something that's, let's say, an ELF object file. What you would really have to do is to go around to a lot of the different places where we're generating calls or accessing data, that kind of thing, and generate a different instruction sequence potentially, depending on that actual target that you're producing. It's certainly possible that you go around to every single place that's emitting one of these pieces of code and doing something different there. But what I was trying to think of was if there was a more a cleaner way of representing this. So what I came up with is in something that I've been calling an object format, for lack of a better name. But really what the intention here is to look at places where we are generating, I'm just starting with calls for now. This certainly would extend to data as well at some point, but just starting with calls, which is the main thing that I'm interested in to begin with. How can we sort of abstract what it is that we're doing at all the different places that we're generating calls so that we can change the instruction sequence depending upon the target that we're trying to target. So if I'm generating an object file for ELF, it needs to generate stuff that cares about the PLT and perhaps a global offset table. I'm generating stuff in for a JIT compiler, maybe what we have right now works just fine. So I'm trying to hide a lot of that decision logic behind these things that I'm referring to as object formats. The other thing that it's going to do to our current code, I didn't mention this before, was that we also make assumptions. We impose decisions on consumers of OMR on things that they may not want to make a decision on. So, for example, the way that the code is written right now assumes you're generating code into a code cache, and it also assumes that you're going to need to care about trampolines when you're calling other methods or calling natives or things like that. So that may not be something that is important to you or even applicable to you. So it would be good to hide that away so that you don't have to deal with it. So what I'm thinking of is what we can do for all the different call family of instructions. So this doesn't just apply to calls that come from the IL. This could be anything that is being generated, any kind of call that's being generated from the code that you're generating. So this could be to a native, it could be to another an entry in another shared library, it could be to a VM method, it could be to a helper, something like that. They're all different kinds of calls, and potentially they would each need a different kind of encoding depending upon the target environment. This doesn't really, this isn't about the linkage. The linkage is really about the calling convention that's being used in order to, like, from one function to call another. This is really just about the encoding of the instruction and the things that the target environment requires that we do in order to encode that correctly. But certainly the pairing of a linkage and an object format is what you would need to emit the proper call sequence. So what I am thinking of is introducing something called an object format, an extensible class to encapsulate the encoding of a function call. The idea is that object format itself will be abstract. It's going to provide APIs that must be implemented by specialized object formats, and depending on whatever makes sense for your language environment, you install the right object format for that. So for example, like just some examples I'm getting here, a JIT code object format, again, for lack of a better name, that we could use for dynamically generated code that's executed in place. So this is pretty much what we have right now, and anything that we do right now would fit into that kind of an object format. ELF is another possibility, Macho on Mac OS, XCOF and AIX, that kind of thing. So if you want to generate different kinds of calls, you install the right one for your target. I expect that the initial API, if we're just focusing on calls, to be quite light to begin with. At this point, I'm thinking of just a couple of different kinds of calls. So one I've been calling a global function for, again, lack of a better name. So it's basically any kind of a call to something that may not be in the code that you're generating. So this would be like to a native or something to the VM or something like that. And then there's the notion of calling something within the code that you're generating, or within the code cache of something that you're generating. So that would be what I call a code cache function call. And it's certainly possible that you would get different encodings for these two different kinds of targets, but they could also be very much the same. They could generate exactly the same kind of code for both. So if we are able to provide that kind of abstraction, the kind of work involved would be to pretty much visit every place where we do a call in generated code and change it to use an object format. Now, one of the things that I discovered while thinking about this and trying to think about how this could work across platforms is that every backend that OMR supports, even though they are very similar in terms of the logic, the way that they actually implement different kinds of function calls is very different. And the requirements that each of those sites have to make the decision on what to do is quite different. And I mean, there are similarities, like they usually start with a symbol and they have a node, but beyond that, there's lots of other pieces of information that each backend uses in order to make the right decision on the call to do. This is definitely unfortunate, and I don't think it necessarily has to be this way, but just given the way that the different backends have evolved over time means that there's a lot of information often being consulted in order to make a decision. The reason this is important is because if I'm trying to come up with a single API, a nice clean API that every backend just really needs to implement, there isn't really a nice, easy way to do that because of all these differing pieces of information. So the way that I solved that was to introduce another kind of structure that these object format function call functions would take as their parameter. And I've been just calling it a function call data class. And every architecture can populate this function call data with, they can specialize that data structure the way that they want, and they populate it with the data that they need in order to emit their function calls at these different sites. So it itself is going to be another extensible class. I'm going to show you a bit of code in just a sec, and you can see how kind of ugly it starts to get under the covers. Going forward, I don't necessarily think it has to be that way. I think that over time, we can certainly clean up and reduce the amount of information that's required at each kind of call site, and perhaps even common up some of that across the different backends. But just starting from the state of the world right now, it's there's a bit of they're definitely discontiguous. So, and as I mentioned before, object format should apply to both functions and data. But what I'm really proposing here is just talking about function calls for now. Over time, I can see that as we start to target, or as this code starts to target other static contexts where we need to deal with data, that we're going to need to have some kind of a solution in place for encoding the different kinds of memory references and that sort of thing. So what I'm going to do is just to give you an idea of what some of this code might actually look like. I put together just an example PR of how some of this code could actually look. So I'm just going to start with object format itself. Oops. Here's my OMR object format. All right, so extensible class. And in here, it basically just contains a bunch of abstract APIs. So I've got one for emit global function call that takes as its parameter a concrete function call data. And I'll show you how that gets populated on x86 in just a sec. So there's two different kinds of functions that are being introduced. One is an emit and one is an encode. And the real difference between them is that emit will generate TR instructions. It'll add TR instructions to the instruction stream in order to emit the call. So this is useful prior to register assignment, like during tree evaluation. And then there's a corresponding one called encode, which is useful after register assignment, let's say during binary encoding, or if you're generating snippets, something like that, where you want to generate a call, but it's really just going to produce the actual binary encoding for that call. They're similar, but they just have different kinds of outputs. So I have two functions for that. I have one for asking for how many bytes are going to be emitted in this sequence. So it's useful for code sizing purposes. And then I have a corresponding set of functions for calling functions in the code cache itself. And like I said before, it's certainly possible that these functions map to the same kind of implementation up here. It really depends on your language environment. These are all pure virtual functions as well. So any object format being extended from here must implement those functions. So that's that. Did I add any? I don't think I actually specialized that, but so once the concrete class is produced, so you have a tr : object format, the expectation is that you can specialize, you can provide specialized versions of this. So here is a JIT code object format that extends the tr object format. In this particular location, it doesn't actually provide anything other than just sort of the anchor point for that. The idea is that JIT code object format would do exactly what the code we have today does. So whatever the implementation is, it's been sort of repurposed into this format. The other thing that I wanted to just quickly mention now that I see it here is that I've introduced a new directory here called ObjectFormat. It would be a similar, it would be a sibling to CodeGen or Optimizer or any other top level directories. The main reason I did that was because I guess it wasn't strictly required. I guess some of this could live in the CodeGen directory, but the number of object formats, if we're going to start to support a lot of these, is going to start to accumulate. So right now I've got ideas for a JIT code object format. I've got an ELF object format. There's a Macho object format. I've got hybrid ones as well. So ones that if you wanted to have an executable ELF format, so you generate ELF code, but you also want to be able to execute that ELF code dynamically while you're generating it. So we need a different format for that. So those are starting to accumulate. So I produced those in their own directory just to keep things a bit cleaner. But what I wanted to find was the AMD64 object format. So here is an AMD64 implementation of the JIT code object format. And what it really does is provide an emit global function. Within its emit global function call, it does take this sort of larger data structure, a function called data, that's got, and I'll show you how that gets populated in just a sec. But what it really does is it follows the logic that's currently there in the code to figure out what it is that I'm trying to call and how do I call it. And there's lots of pieces of information that it tries to draw from in order to do that. And it can find all this information that's in this data structure. So if you've ever looked at the dispatch logic for different places, it's all been sort of unified into this one blob of logic here that I'm not really going to talk through because it's all code that's already there. So I certainly do think that some of this could be simplified and condensed, but that isn't at this point not the purpose of this exercise. So what this will end up doing was, because this is the emit function, it'll go and produce TR instructions, and then it'll return the final thing that it actually ended up generating. Encode is pretty much the same. In many cases, it can actually be much simpler than this. So for a JIT code object format, it's really just either a call or a jump that we end up producing directly to some address that we already know about. So that's what it does currently. I didn't show you the function called data yet. I forgot to do that. Called data, which itself doesn't do anything, but it's the specializations that where things get interesting. No. Oh, actually, there's got to be something in here. Nothing in there. Sorry, I'm just getting oriented here. Where are we? Right. Okay, so this is the x86 AMD64 version of function call data. So the way that this looks is there's a lot of pieces of information that may need to get passed in here for it to make the right decision. And to try to simplify this a bit, a lot of these, it provides a number of different constructors. And a lot of the information is actually set by default. It isn't required at a particular point. And as we start to spread this out throughout the code, you'll see that in some cases you have some of this information, and in some cases you don't. So there are different constructors for those different kinds of applications, where if you don't have the information, there will be a sensible default option provided. So there are suitable APIs for calling global non-helper calls. There's some for if I'm actually calling a helper call. If I'm calling something from the snippet, I'd want to use something like that. So here's an example of here of where, now where you have, too many WebEx things in my screen here. So the code generator is responsible for knowing what the target object format is for this particular compilation. So it stores the object format. And so if you want to know what it is, you ask the code generator. So I've got two examples of where I'm using this. The first is in system linkage, where this is where we're actually doing the call to the native. This is in build direct dispatch. So all of this other code is sort of been removed. And what we do for all these different call sites is we end up producing this data, an instance of this data, function call data, and we pass in the various bits of information that are all being used up here to make this decision. And then that data, a reference to it, is passed into emit global function call, which basically unpacks what it needs in order to, for this particular object format, and does what it needs to do. So it should be, I mean, if you ever wanted to change this to going from JIT code to an ELF object format to a hybrid approach, whatever, it should be, all you would really need to do is just to change the implementation of that object format in the code generator, and it should just happen transparently to you. So it's really getting rid of all this extra logic and this specialized code for knowing, oh, I need to call indirectly through a register. I have to call through, I'm calling this directly with a 32-bit displacement, that kind of thing. It's getting rid of all of that and hiding it underneath this global function call. That's one example. Here's another example within Tree Evaluator. I think it's a helper call here. So the code or the initialization to call a helper call is much simpler. You just need the index and perhaps some dependencies, and then away you go. So I'm just going to stop there just to sort of see if there's any comments on this approach. Any feedback? I will say, sorry, before I maybe open it up for questions, that the population of that data structure, I do need to study that a little bit more just to make sure that we're not incurring more of a performance overhead than a compile time performance overhead than we should be. Part of it comes down to reducing the number of things that we actually need to make a decision on, so that way you don't actually have to store them into this data. This is actually just a local object. It's stored on the stack here, so it gets cleaned up at the end of when it goes out of scope. So it's not allocating any sort of scratch memory or anything like that. The data structure itself is pretty small. It's got to be in like 64 bytes or 64 to 80 bytes, something like that. But it's the actual writing into that data structure of all these different things could potentially be problematic. But I haven't quite, other than reducing the number of those, I haven't quite thought of a better way of doing that yet. So, and I'm pretty sure that this approach also works on Z as well. I know that there's been some prototyping work happening there as well. So I know it will scale beyond just x86. Anyways, stop there now and take any questions, feedback.
So one question for you, Daryl. One of the things that OpenJ9 is interested in at the moment, as part of value types being added to the Java language, is linkage optimization. So being able to carry objects that might normally need to be put into boxed and passed as a reference in the general case, being able to optimize the linkage by passing values in registers and things where they'll fit. I was just wondering how you might see that kind of thing playing into this design that you're proposing.
When you say linkage, do you mean the OpenJ9 definition of linkage, like the calling convention, or do you mean linkage as in like the extern and the scope kind of linkage?
I mean, as in the OpenJ9 definition, okay. As the way that the arguments are being passed and what the convention is between the caller and callee.
So is the linkage now going to be specialized by call site then? Is that what you're saying?
It's not necessarily by call site. It might be by target. So if we've compiled a particular target in the JIT, and we have a JIT entry point that will accept the value type being passed in registers, and the interpreter entry point will have to accept it boxed. But that basically, rather that we would have these different like you may have to want to do different things depending on if you know you had a compiled target that you were going to, for example, and that would deal with some of that.
And would you always know the linkage at compile time?
I think doing an optimized linkage, you would be able to know at compile time, right? Like if you didn't know at compile time, you would go with some generic linkage that would always work.
Okay, so if you speculate on the target, you know what you're going to be calling. You can then therefore speculate on the linkage as well. Yeah, I mean, I think that so this deals with the encoding of the actual call, but linkage. Every call site is actually just a pairing of the linkage and the object format. So we would almost need to have some kind of a higher level structure that actually paired them, or have them on like a symbol reference or something for a particular, or kept that information on the symbol reference perhaps for a particular target. But keeping them as a pair, I don't think would be. We'd have to find the right structure for that, but I think we could do that. Not sure if that answered your question or not.
Sort of yes and no. I guess I'm just trying to figure out how we would try and avoid, like an explosion of combinations that may end up being poorly tested in some situations, right? Just because, like the value types implementation is going to want to pass values in register by preference when it's possible, but in general, because the interpreter treats everything as boxed, there's kind of these different conventions that we have to have. And I know this is very OpenJ9 specific, but I just thought it might play into some of this design.
I mean, well, from a testing point of view, I mean, one of the things that we could do on every call site is to not just assume the linkage is whatever the code generator tells it. Like we have to get a site-specific linkage or a target-specific linkage. But we could certainly, you could certainly do some testing based. Like you could provide. You could certainly change that linkage then and test out different combinations. I would think. Yeah.
Okay. All right. Thanks. Yeah, it isn't really an objection to your design. It was just something that the OpenJ9 community is looking at, and I was just trying to figure out how it fitted with what you were saying.
Yeah, I'll give that a little bit more thought as well, and just to clarify in my mind what you have in mind. But yeah, I think that there are some extension opportunities even just beyond global function calls. Extending this for linkages as well, I think could happen. So.
Thanks.
For what it's worth, off the top of my head, I think that, so in the OpenG9 case of value types, I suspect a lot of the work we will want to have happen in the linkage. So most of the information we will need, barring significant refactoring, I believe will be in the IL, not in the instruction stream. A lot of the information we need to do those optimized calls with value types. So my guess would be that all of that sort of handling would probably stay in the linkage. Whatever kind of handling would probably have to happen at a higher level than this. Just because I suspect that by the time we get to this level, we won't have enough information to do the proper decisions. So unless we somehow try to like propagate all of the information all the way through, but that would be costly, I would think.
Yeah, I'm not quite clear yet in my head how it would fit together. So I was just mentioning it because it is something that people are going to be wanting to look at. And if we're playing in this space, it kind of makes a bit of sense just to think about it. But I think you could also be right. I think there's just some dimensions that we should all consider in these different extensions to what we have.
Yeah, no, agreed. It's definitely something we have to think about. My gut feeling is that it should happen at a higher level. But yeah, we'd have to think about it some more to really say for sure. So Daryl, if I can try to briefly summarize kind of the design you have here. So you have ObjectFormat that is an extensible class, right? Mm-hmm. Then it's an extensible class, but it kind of acts as an interface. And the expectation is that we then have various realizations of that interface for the different kinds of object format. And each of those will also be an extensible class?
Yes.
Okay, so we have an extensible class that extends another extensible class then.
Yes. I mean, this isn't the first time we've done that, but
yeah. No, I get it. I'm just trying to make sure this is the pattern we're actually following here.
Yeah, I mean, the actual use of an extensible class. Sorry, it's only the specialized classes at the moment that are making use of the fact that it's extensible. Like they're the ones that are providing the specialization for architecture or project, whatever. If you look at from what I've seen so far with just the object format base class, I haven't yet, in the way that I've done it, found a need to actually provide any specialization beyond what's in the base class. So perhaps the very base class doesn't need to be made extensible, but I'm just trying to make it as flexible as possible, I suppose.
Okay, yeah.
But I am worried about over-engineering too.
That was going to be my... Sorry, go ahead.
Well, I don't want to over-engineer it if I don't have to, but it's I am providing the flexibility points here just in case there is some implementation that needs to provide some specialization to the base class. I'm not sure if that's needed yet, but I don't know.
Yeah, okay. That was because, yes, that was going to be my next question. Just it's not clear to me yet how what the value is of having both classes be extensible.
Well, it would be a shared. I mean, if a project wanted to extend the object format in some way, and share that extension point with all the other or share that API with all the other specializations. I guess that could be one way of doing it. But again, that's maybe thinking about problems that don't exist yet. So perhaps the base
So the
class
way I'm
itself could
thinking
be
about it,
simplified.
right? So the way I'm thinking about it is, so I guess when would a user want to extend the base class? So off the top of my head, an example would be if, say, there's something other that they want to do special that's not a function call or data, or maybe a different kind of data that they need to handle specially. In that case, let's see. If you want, you would only need to extend the base class if there were parts of the code that need to know about this extra behavior that also don't know which specific kind of object format you're dealing with. Okay, I can imagine something like that happening.
Okay. I mean, the reason I left it as extensible is because it actually wasn't that much work to leave it as an extensible class. But but like I said, I haven't really found a use for it yet. It's just a way of it's just providing a feature that may not be immediately useful, but it's not a huge amount of effort to provide that feature. So if there is, if the feeling is that we should just make it extensible later, should we need to extend this, I'm fine with that. But if it's going to improve the understanding of the code, but I'm open to.
Yeah, I'm just kind of trying to think it through right now. I'm probably going to need more time to think about this.
Okay. The one piece of feedback that I was hoping to get, if there's other ideas on, was if there was a different way of structuring the API. Like if you look at that function called data, it is a little bit ugly, and a lot of that is hidden from developers behind the different constructors. But if you actually get into that code, it's actually kind of ugly looking at all the way that you can compose that. So I was wanting to ask if there's any other suggestions on how to provide the myriad of information that's needed at these different call sites to determine how to encode how and what to encode. So that's one thing that I was hoping to maybe get some feedback on, if there are any other suggestions. Otherwise, go with this.
I mean, off the top of my head. Sorry, Philip, go ahead. I was just going to say, off the top of my head, it sounds like the structure you want is an extensible variant. So you have basically a variant of different tuples, and each variant corresponds to a different kind of call and only contains the information you need. There's no straightforward way of implementing that in C++, at least not in the versions of C++ we support. So yeah, I can't really think of a better approach right now.
Okay. Sorry, Philip, did you have a comment? Or?
Yeah, I was just going to mention having experience porting some of to C. I think what you have here is actually pretty good given what we're trying to achieve. There's quite a lot of ugliness, and I think we can we can get rid of some of that by partitioning. I saw some of the constructors have like 13 or 14 different parameters or something crazy like that. We can for sure trim down the number of overloads we have of the function called data, and kind of standardize that across the different cogens. But at the end of the day, like all the object format is doing is just querying the function call data to get, for example, what is the function address that I'm dispatching to, or something like that. It's not doing any heroics.
Okay. All right. Well, thanks for that feedback, actually.
I personally found that the code looks a lot clearer, at least if you just ignore the ugly bits hidden behind the function call data.
Yeah, actually, when you get it down to just doing an emit or an encode function call, it does seem to simplify the code quite a bit. It makes it a bit more readable, that's for sure. So my next step here, if there weren't any sort of glaring objections to anything that's being done here, is to start to introduce sort of roll this out in some stages. It obviously needs a bit of documentation. I think I provided some here, but I think I could do a little bit more, and start to make some of the changes to the code to introduce it. It turns out there actually aren't that many places, at least in OMR, there aren't that many places right now that actually need these calls on x86 64. So that's a good sign. But no code generator really absolutely has to implement this right away. It's not like we introduce something and it's going to break codegens that don't support this. Codegens can introduce this up there as they need it. But I think that at some point it would be good to have all codegens sort of converge to the same thing. And similarly in downstream projects like OpenJ9 and making changes to the various calls that get emitted from the code cache, making them use global functions as well. So. Okay. Any other comments before we wrap up? No. Okay. If that's it, then that's the last item on our agenda for this week. So thank you everyone for participation, and we'll talk again in 2 weeks. Thanks.